Assalamu alaikum. Today we're gonna start our first experiment for electrical circuit. So, going through the outline, we start to state the objective of our experiment. We mean by that what we're gonna expect and learn from this experiment. Uh, by the way, we're gonna spend some time on the theory part from this for this experiment, since our practical experiment doesn't take long time. So let's start to define some definition related to the electrical circuit, and then we're gonna go to some exercises related to the unit prefixes. We're gonna talk about it in a few minutes later. Then we're gonna define our lab equipment, what we're gonna use it regularly in the lab, and after that we're gonna start the experiment. Our objective for this experiment is to understand and to know the basic component for any electrical circuit. The second thing, I'm willing to all of you know it, is how to convert the unit or the prefix of units. Then I want all of you to get familiarized with the lab equipment, and so later on when we go in the lab, you know which equipment we gonna use. And we'll talk about a little bit in how to use the breadboard, and this is more related to the practical part. We're gonna study the color code for any resistors, and after that we're gonna learn how to use the ohmmeter. So a little bit introduction about the electrical system. So as all we know nowadays, the usage of electricity is considered one of the daily life necessity. We don't get rid of it. We need to understand and how to use it safely without wasting it. So in order to know or to do that, we have to study the concept and the basic of this electrical system. So basically, when we talk about electrical system, it's just a group of components connected together to perform a desired function based on electrical charging or charges passing through this system. So the main source for this system is electricity, and we want out of it some application. This is some of the application we know. So you can see it in mobile phones, airplanes, so it varies from different sizes, and all of you know and see it in our daily life. Even the light, we're gonna see how to understand the basic of it. So for any system, we need to learn the energy source, the system itself, how it's connected, and how this energy delivered from the source to the application that we want to turn on. So for example, the car, you know, that consists of wheels, engine, and it's connected together, and the energy we supply it by fuel or gasoline in order to move the car. Similar way, we want to see it in the electrical system, but as we talk about the electrical system previously, we see that it's based on the electricity. What is the electricity? So in the car example, you see that gasoline, we can see it, we can smell it, or we can measure it, but in our case here we have some quantity that we cannot see it, but we have some way to measure it. This quantity gonna represent our energy source, which is the electrical source, and this source we're gonna move through our system in order to supply or to operate a device or a tool or anything need electricity to work on. So this source, we call it electrical charges. This is similar to the fuel. So if you see it as the fuel in the car, this is the element or the source that's gonna move inside the electrical system, and we measure it by unit called coulombs, and once we represent it in the equation, we're gonna represent it by kiloliter. So from later on we're gonna define some definition, and we'll learn the unit for it, for what's the unit or how we measure it. So when we talk about measurement, we want to see the quantity of it. So the charges, we measure it by coulomb. In simple example, if I have some length, I can measure it by meter, centimeter. This is similar way. And once it comes to equations and how to find the law related to these charges, we're gonna represent it by Q. I hope you understand this very well, because later on this unit and variable will gonna increase with us. So be careful with it and learn it from the beginning. So moving on, let's talk about the container and how to supply this charges to the system, or how to deliver this charges to the system. Let's move to other example rather than the car. If I have like water tank in my house, I want to deliver the water to the house. In this case, I need to have some pump in order to push the water through the pipes to deliver it to the house. In similar way here, the pumps or the element that we're gonna push the charges out from the source, we call it voltage. And this is like detailed definition for it. We will define it as difference between electrical potential energy. So as we agree that we have electrical energy, the difference between the levels. So this is like the water container. If I'm having large distance, we mean that I need to apply more force to push out the charges out from the tank or the source. So this is the tank, this is the pipe in the water example, but in our case here we're gonna use wire to push the charges out from the source. In this case, the battery is the good example for electrical source. So battery, if I look it as a battery, it uses some chemical process in order to push the charges out of it, out of the battery, to deliver it to the circuit. So pushing out the charges from the battery, we call this as a voltage. How much power or how much force I need, we measure it by voltage. And the positive negative terminal is gonna represent the direction of the current, or the direction of the charges from where it gonna goes out, and we're gonna see it once we gonna define the current. But let's agree on what's the unit for the voltage. So whenever I ask you what's the unit for the voltage, we measure it by unit called volts. And if we want to relate it to the charges, this is the formula. So it is just energy joule per coulombs. So how much energy per charges I need to push out the charges. Once come to equation, we're gonna use this letter, phi letter. Doesn't matter if it is capital or small, but most importantly, I want to know the unit is volt. And once comes to variable, I am gonna use this symbol or this variable letter. As I said, very obvious example is the battery. And once come to circuit, later on we're gonna see example of circuit diagram. This is the symbol of the electrical source or the battery. Also this sometimes we're gonna see it. Most of the time this is the battery. This is the battery, and this is another supply, as we're gonna see it in the lab. This is the most likely representation for the power supply. Moving on, the second element in our circuit is the current. As I told you, the charge is coming out from the battery or the electrical source. We're gonna move. This movement of the charges inside the circuit, we measure it, or we call it the current, and the unit for it, we're gonna measure it by ampere. In other words, I can see it as the velocity of the charges, how much charges I have per second through this circuit. And the variable, when I want to relate it or write it in formula for the current, I'm gonna use I letter. Usually the direction of the current moving from the positive terminal to the negative terminal. So if I'm having circuit, most of the time the current move out from the positive terminal and gonna go through the circuit and come back to the negative terminal. So this is the usual direction for the current. Since it's electrons, we most of the time represent it by this way. So this is the way how the current we're gonna move. Start from the positive into the negative. This is important to know once it comes to measuring the current, but put this in mind. So once we want to connect and how to measure the current, we have to make sure that the current should go from positive to negative. So from now I'm having voltage as electrical source that push out the current from the source. I'm having current moving through the pipes, but how about if I want to control the amount of this current? So for example, if I want to use some tap to drink water, or use the water to take a shower, so we have different kind of application and different amount of water we want to come out from these two examples. So in order to control the amount of charges, similar to the water example, we have here element, we call it resistor. Resistor is just an element inside the circuit that we're gonna control and limit the amount of the current moving inside the circuit to prevent it from damage. So I need to be careful to choose the value of the resistor in order to save the circuit from damage. If I'm having a huge amount of current inside the circuit, but I'm having a low resistor or element that will not control this amount, by the end of the day the circuit is gonna be burned. So to make sure our circuit works safely, we need to choose the right resistor in our circuit. So the resistor, we're gonna measure it by ohm, and once it comes to calculation or represented in the equation, we represent it by letter R. So whenever we see R, we talk about resistor. And once it comes to measure the value for it, we're gonna measure it by ohm. And this is the symbol for it. We have two different symbols. Some book use this rectangular shape, and most of the other book use this zigzag shape. Another definition related to the resistor is the conducting or the conductor and insulator, which is somehow can be defined by the resistance. So as we define the resistor, is just the property of material that conduct the electricity to allow the current to move. And this is the meaning of conduct. But let's try to define the conductor as a resistor. How much value for it, and what type of material used as a conductor. The basic example we see it for conductor is the simple wire in circuits. this is most likely made of copper or gold or silver. Depend on the application, depend on the circuit that I want to create. I need to choose the material, the good material to conduct the electricity. So most of the time this is copper. We're gonna use it in our lab, but gold, silver example, we never see it in our lab, since it's obviously it's very expensive. But if it is very sensitive application like computers, they using the gold, very thin wires made of gold in order to make the circuit. So conductor is just a low resistor material. So since it's having low resistor, it means that will allow all the current to move. I will not limit or prevent any current to going through the circuit. And simply when I want to measure it, we're gonna see it's having very low resistor. And if it is the ideal situation, I'm gonna have 0 ohm. 0 ohm, it means that all the current is gonna pass out from the battery. But this is not in our lab is not practical, since the copper have some resistor, but it's very low. If you try to measure it, you're gonna see it have almost equal to 0. By the way, if we're having low resistor material, we call this circuit as short circuit. It's a typical example. If I'm having the battery, just connect its terminal, the positive and negative, by simply wires. So this connection we call short circuit, and obviously you can see that all the current will gonna go out from the battery and come back, but we're gonna damage the circuit in this case, since I'm not limiting the current, the moving current. So doing this connection, we're gonna burn the circuit, and this connection we usually call it short circuit. And this is what happens once if you have like something burn in your house. We have some material that once the current once the resistor is damaged, the circuit is gonna be breaked by breaker. This is different, or another term for it is the fuse, if you heard for it in your home. So this fuse is gonna cut out of the circuit to prevent all the current to from the circuit, in order to make the prevent the circuit from damage. So this is what we have for the short circuit. In the other way around, we have insulating material or insulator, which is a kind of material that will prevent all the current to move. If you try to use it as a wire, you will see no current will gonna move out from the battery, or from the battery, since it's having very high resistor. A good example for the insulator is the rubber, plastic, wood, even considered as insulator material. And once you try to measure it, or if you want to see the ideal measurement for the insulator, you're gonna see it equal to infinity. In our lab, we'll not see infinity. We're gonna see the OL, which means open loop, or in other way we can say that this is we having open circuit, which is the opposite definition of short circuit. So as we talk about short circuit, we mean that the circuit is connected through the wire. It's the terminal of the battery is still connected to the wire. But if we're having open circuit, we mean that the terminal are not connected. So obviously here the current will not able to complete the circuit, since there is some element or there is no connection between the wires or between the terminal of the battery. So resistor basically just the definition to define the position from the conductor and the insulator. The resistor that we're gonna use have some value. It's gonna allow some of the current, but not all the current, in order to prevent the circuit from damage. So it's gonna make sure that our circuit works without any problem. This is the resistor, and this is what gonna be our experiment on. So this is the typical circuit that we're gonna see and have. So you see that we have voltage source. The voltage gonna push out the charges. These moving charges we having, we call it current. And to complete the circuit and make sure it's work without any damage, I have to use some resistor with some certain value to prevent the circuit from damage. I have to know the value for the resistor that will make us make our circuit is working efficiently and safely. So we have some formula that relate these three elements together. We talk about it later, but from this experiment we want to know, to create a circuit we have to know to have these three elements connected together. We don't have any circuit that missing out of one of these three. If I'm having current, I'm gonna have voltage, I'm gonna have current, and most likely in our lab, and what we're gonna do for most of the course, we're gonna measure the current and voltage through the resistor. Before moving on the experiment, let's try to define some definition related to the calculation. So whenever we're having calculation and some unit needs to be converted, we have to know these prefixes. So once we talk about prefixes, we mean like kind of definition of the multiplier for the amount of the any quantity. So if I'm having let's say that 1000 meter, you can see that writing this takes some time and maybe take some spaces. Other than that, I'm gonna prefer to use this letter to represent I'm having like 3 zeros multiplied by 10 to the power 3, and I can write the same amount in different ways. So it's just kind of representation of the numbers with the unit in order to save some spaces, be more accurate in our calculation, save some time. So it has many different benefits out of it. But once it comes to calculation, you have to make sure all the units are using the same letter. So if I'm having K meter, I'm having second, they have to make you have to make sure they are in the same prefixes, using the same prefixes, depending on the application. But once it comes to the calculation, you have to make sure they are in the same prefixes or the letters. So this is common prefixes. Kilo, it means like I'm having 30 or multiply 10 to the power 3. Milli, which is the small version of kilo, I'm having 10 to the power minus 3 or 1 out of 1000. Micro is smaller than the milli, which is 10 to the power minus 6. Mega is very huge values. Nano, very small value. And giga, it's very huge value. and I think most of the time you see this once we talk about some digital capacity, but this is not our purpose from this course. But you have an idea what we mean by giga, mega, kilo now once we talk about it to represent the numbers. If I don't have any letter, we mean that I'm multiplying the number by 1, which is obviously multiplying any number by 1 is the same. So to convert from prefixes to other prefixes, if you convert from big to small, so mega is bigger than kilo, you need to multiply by 1000. And if you convert from mega to the base or to nothing, you need to multiply twice. So you have to multiply 1000, then multiply again by 1000, and so on until you unify your unit. So this is like the very straightforward way to convert from prefixes to other prefixes, but we have an example that will show you an easier way to convert if you have different letter or different prefixes. So if I'm asking to convert 0.02 mega ohm to kilo ohm, rather than going back to the picture I showed you earlier, I prefer to following this procedure rather than to know which one I'm gonna multiply, which way I'm gonna divide. This way we're gonna save you from thinking out of this situation. So the first step, put your unit that you want to convert from and you convert to. After that, just write down the value of it in tens to the powers. So this is mega, which is equal to 10 to 6. This is kilo, which is equal to 10 to the power 3. Then just take the power out of the 2 and subtract them. So subtract the 1 on the left from the on the right, and this is obviously equal to 3. After that, you just go back to your original question or from where you want to convert, and just neglect this unit. So just take the number, multiply it by 10 to the power the resultant from the difference, which is 10 to the power 3, and by multiplying that you're gonna find the equivalent for it in kilo. If you follow the traditional way, it's okay, but I just want to explain this in order if you have a problem with converting from big to small or small to big. So this is some exercises from different values. If I want to convert 300 millivolt to volt, so milli, I'm converting from milli to the base. So this is the one I want to convert from, this is the one I want to convert to. Milli I know is equal to 10 minus 2 power minus 3, and if I don't have anything or the base, it means that I am having 10 to the power 0 or 1. Then subtract the first one from the second, which is here minus 3, and taking the number, multiply it by the new power, and this is the value. Similar way, so in this case I'm converting from ampere to milliampere. So be careful here, I'm only looking for the letter, I don't care about what the number have. So I'm converting from ampere to milliampere. Ampere, as we know, 10 to the power 0, milliampere 10 to the power minus 3. Take the power, subtract the old one from the new one. So minus multiply by minus, it's positive. With the new power here we having 3. So you just take this number, put in the calculator, multiply it by this new power, and this is the result for converting from ampere to milliampere. Very straightforward. I don't want you to restrict yourself to follow this step, but this is, if you find it easy, you can find it. If you find the previous or the traditional way is easy, you are free to use whatever you like. Now let's go to the lab equipment and talk about each one of them. To know, once it comes to the lab, you know which equipment that you're gonna use. Breadboard is the board that you're gonna place your element on it. Is your workplace, how to connect your circuit. This is what we call it, breadboard. Power supply is considered as electrical source, as a battery, but the battery, as explained in the first lecture, it's just having fixed value of voltage, and power supply can supply different value of voltage, and I can supply more than the battery. Multimeter is the device that gonna measure our electrical quantities like voltage, current, resistance. If I'm measuring the resistor, in this case I'm gonna call it ohmmeter, related to the name of the unit of the resistor. If I'm measuring the voltage, in this case we're gonna call it voltmeter. If I'm measuring the current, in this case we're gonna call it ammeter. The general name for it is multimeter, which is gonna measure different amount. If I'm having specific value that I'm gonna measure, this is the typical name for it. So don't be confused. Multimeter is the general name, and the one related to the unit is the one that I'm gonna measure. If I'm measuring the resistor, it means I'm measuring the ohm. So in this case, it's called ohmmeter. And this is the way how we present it in circuit. So whenever you see symbol or circuit symbol inside it, the unit, it means that I'm using multimeter, or I'm using ohmmeter, voltmeter, ammeter, depending on the circuit. In our experiment today, we're gonna only use the ohmmeter. So in our experiment today, it's very simple experiment. We're gonna use breadboard, the workplace where we're gonna put our element, ohmmeter, which is the one gonna measure the resistors, wires to connect our circuit and how to connect it to the ohmmeter, and we're gonna use different value of resistor. So now comes the experimental part. We start to read the value for the resistor from its color. So as we agree in the beginning, the resistor value will gonna tell me how much current is gonna pass through the circuit based on the resistor value. So in this purpose, we're gonna learn to know the value for it from its color. So we're measuring the resistor again by ohm. So put this in your mind once we talk about how to measure the resistor. Color code is very simple, basic way to know the value of the resistor. We have like this is the typical shape of the resistor. It is cylindrical shape and made by ceramic material. This is gonna insulate the current, isolate the current. That's why we're using resistor to limit the amount of the current, and it has some colored strips on it. This color strips are gonna indicate for me the value for the resistor, and I'm having like two ways of coloring the resistor in our lab. The first way I'm having 4-band color, and the second way is 5-band color. If I'm having 4 colors, then I'm gonna use this table to find its value. But you have to put in mind, if I'm having 4 color, then I'm gonna use the first color to find the first digit from the value of the resistor, second color to find the second digit from the value of the resistor, the third color I'm gonna ignore this column. Since I'm having 4 colors, so I'm gonna directly go to the multiplier, and the fourth one is gonna show me the value of the tolerance. I'm gonna talk about the tolerance in a few minutes, but let's find the value of the resistor for 4-band color. So if I want to find the color, I go from the left side for this resistor, and corresponding to each digit with the right column. So the first color go with the first column. So the first color here is green. I'm having in the first digit, or the first column is 5. So this is the first digit from the resistor, 5. Second color is blue, and this is from the second column, which is 6. Since I don't have since it is 4 color, I'm not using this column, and go directly to the multiplier for the third color. So if it is yellow, it means that I'm gonna multiply the value by 10k ohm, which is 10,000, or in other way 40. So multiply by 10k ohm. This is the value for my resistor. So this is not a good way to write the values. Either you convert this kilo to ohm, or you multiply this 10 by 56. So the final value for it is gonna be 56 or 560 kilo ohm. So I just keep the kilo ohm and multiply 10 with 56, or you can just convert kilo ohm to ohm, which is obviously gonna equal to, so this is supposed to be 0. I'm facing problem with writing the number. And you can see that writing too many 0 is gonna take some spaces, and we don't prefer to use this. Most of the time we write it in kilo ohm, or if you want to count it, write it in megas, better, but kilo is okay. And this is most used way to write the value of the resistor, kilo ohm. Oh, what about the tolerance? Tolerance, we find it from the last column, corresponding to the last color from the resistor, which is here silver, and the tolerance should be equal to 10%. What we mean by tolerance is just percentage of error of the actual value of the resistor. So if you try to measure it in practice, we don't find it exactly 560 kilo ohm. It's gonna be more or less than this value by 10%. So this 10% is gonna tell me the limit, the lower limit and maximum limit of the this resistor. If I want to calculate it, so just multiply this value by 10% and then subtract for the lower limit, and if you want to find the upper limit, you multiply by 10%, add it to this number, you're gonna find it, you can find its value. I'm gonna show you an example after this slide, so don't worry about it and don't be afraid about the calculation. Our purpose from this experiment is how to know the value of the resistor from each color. I don't ask you to calculate the upper limit, lower limit, but to know what's the meaning of tolerance. Okay, so moving on the second resistor. Since I'm having 5 color band, I'm allowed to use this column based on the given resistor I'm having here. So I'm having 5 color. Start again from the left, go color digit by digit. So the first color go with the first digit, which is red, equal to 2. Second color orange, I go to second column, which is 3. Third color here I'm having violet, so violet 7. So this is the value I found it until now. Then the fourth color is gonna tell me how much I'm gonna multiply this number. I'm gonna only multiply it by 1. So since I multiply by 1, I'm gonna have the same value, 237 ohm. So this is, if I want to write it in ohm, you can convert it to the kilo depending on the represented value that you have. So if you ask to convert all the value of the resistor to kilo, you have to convert it to kilo. Otherwise, you don't need to convert it actually. Then the last thing the last color for this resistor is brown. It's gonna tell me the tolerance for it, which is 1%. So my lower limit here is restricted, very small, since I'm having low tolerance. So this is basically how to know the value for the resistor from its color. Now let's have some example to know how to know the value of the resistors. So if I'm giving this resistor and I ask to find its value from its color. So the first color here is red, the second color blue, third color black, fourth yellow, the fifth silver. So first thing that you have to put in mind, what kind of resistor I have, 4 color or 5 color. Here I'm having 5 color. I'm allowed to use the table, all the table. I'm not neglecting any columns. If you look back from the table, you're gonna see this is the value for the resistor, and the tolerance for silver is 10%. I made some calculation for the tolerance to see the lower limit, upper limit. So the actual value should be between this number and this number. So if you try to measure it in the lab, you'll not find it equal to 2.6 mega ohm. You're gonna find it between these two numbers, either 2.4, 2.5, depends on the resistor. This is like a factory error made by the factory, so don't worry about it. But our purpose here is to know the value for the resistor from its color. The second example here, I'm having 4 color. So since I'm having 4 color, I'm gonna neglect the third column, so I'm not using it. So if I'm having violet, orange, so this is equal to 7, orange 3, black as the third color goes directly to the multiplier. I don't add 1, I multiply by 1 since I'm having 4 color. This is the value for the resistor, and this is the tolerance. And you can see lower tolerance, low range of restriction of the value. So it should be, the value of the resistor should be lay between these two numbers. Yeah, this is it as how to know the value for the resistor from its color. Now let's go to the second part. The second part of the experiment is gonna be filmed in the lab, and you're gonna use the ohmmeter. You're gonna learn how to use the ohmmeter to measure the resistor. So after watching this video, you're gonna learn how to connect the multimeter, how to deal with the breadboard, and how to measure the resistor. After finishing this video, I'm gonna ask you to fill the following table. So this table just to compare what you find from the color with what you find or what we found from the ohmmeter or the lab experiment, and just try to compare for different value or resistor. I'm not asking to write it down and show it to me, but this is for your learning purpose to compare between the two value. If they are close to each other, then your connection is right. And this is it, and see you next time.